In this video, I'll be covering question 4, part C from the 2012 AP Calculus AB free response, no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. So part C here gives us this new equation g of x, which is this piecewise function, and they want us to be able to tell them whether g is continuous at this value x equals -3. And we need to use the definition of continuity to explain our answer. So we'll start with what the definition of continuity is. So for something to be continuous, it has to fit this definition. The limit as x approaches some number of our equation has to equal the function value. I always just say the limit needs to equal where you would put a dot on the graph, where that y value would go. For this problem, we're worried about a value of -3. So the first thing I would want to do is figure out what is the limit as x approaches -3 of g of x. When we look at our piecewise function down below, we'll notice that conveniently -3 is where this function splits into two different equations. What that tells us is we're going to now need to break this one limit up into two limits. We're going to need to have a left-hand limit. I'm just going to call that LHL. We'll need to find what is the limit as x approaches -3 of g of x. Get an answer out for that, and we're going to need to find a right-hand limit, RHL. Oops, so from the left we would put a negative sign up there. And then we would say limit as x approaches -3, and then from the right of g of x. We then go over to our piecewise function and start plugging in what our function would be. So the limit as x approaches -3 from the left, things to the left of -3 would be less than -3. So for the left-hand limit, I'm going to be using the function f of x. Things to the right of -3, the limit as x approaches -3 from the right, things to the right of -3 are things that are greater than -3. That means our right-hand limit is going to use the equation x plus 7. F of x was given to us, working back on this left-hand side. F of x is really this function here. So we would be asking ourselves, what is the limit as x approaches -3 from the left of the square root of 25 minus x squared. From here, you do what I just call option 1. Option 1 is just plug that x value in. So I would take and plug in -3. We get 25 minus -3 squared. That's going to be 25 minus 9. That's the square root of 16. So we get out 4. So our left-hand limit, the limit as x approaches -3 from the left of g of x, is going to equal 4. Now we want to compare that to our right-hand limit and see what happens. On the right-hand side, again, option 1 is to take that -3 and just plug it in for x. So on the right-hand side, what we would get out is that this is going to equal -3 plus 7, which is equal to 4. So our right-hand limit is the limit as x approaches -3 from the right of g of x is also equal to 4. Since these two values are equal to each other, our left-hand limit equaled our right-hand limit, and that tells us now that our overall limit as x approaches -3 is going to equal the same value. So our overall limit is 4. So right now we've taken care of this left-hand side. We know what the limit value is. And then the second part is we need to come through and figure out what is our function value. So we would want to know what is g of -3. If we look up again at our piecewise function, we see that the equal sign on our inequality is on the top equation. So g of -3 is the same as f of -3, which we really already did. We plugged -3 in for x up there. So this would again be 25 minus -3 squared. 25 minus 9 gets us 16. This would be the square root of 16, so that is equal to 4. So what we have out of here is g of -3 is equal to 4. Then our final conclusion is just going to compare these two results. And what we can see is the limit as x approaches -3 of g of x is equal to 4, which is equal to g of -3. Those two values are the same, so g of x is continuous at x equals -3. So we would have gotten 1 point for breaking down both of our left-hand limits and our right-hand limits. 1 point total for all of that to get to our final conclusion about our overall limit. And then you would get a second point on this from drawing out that final conclusion that those two things are equal and giving them this sentence right here. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.